This is a HSC physics past trial question on matter waves. Let's look at the following sets of questions. So first bit, determine the wavelength of an electron moving at the following speed, 2 times 10 to the minus 10 to the 7 meters per second. 2 marks. For this, we need to use the de Broglie formula. And that's simply lambda is equal to h over mv, where h is Planck's constant. That's on the HSC data sheet, 6.626 times 10 to the minus 34 joules seconds. Mass of the electron on the data sheet as well, 9.109 times 10 to the minus 31 kilograms. And the velocity is what we're given. That's 2 times 10 to the 7 meters per second. Hopefully the units should all cancel out to give you meters. Okay, they're the SI units for wavelength. Plugging that into your calculator, you get 3.6 times 10 to the minus 11 meters. 1 mark for the working, 1 mark for the answer. So it's a straightforward question there. That's the de Broglie wavelength of an electron moving at that speed. Part B, how was an observation from electron scattering experiments used to support de Broglie's proposal of matter waves? That's 3 marks there. So we need to justify how observations from electron scattering experiments were used to support the theory put forward by de Broglie. Now, the common example is that of the Davison and Germer experiment. Davison and Germer, okay, in 1927, they basically scattered, so here's your response, scattered electrons from a nickel crystal surface. Nickel is the metal. Nickel crystal surface, creating a diffraction pattern. So if you recall, metals exhibit a crystal lattice. So these are the positively charged nickel nuclei right there. Electrons were fired. Here's an electron fired at the crystal lattice, and scattering was observed, indicative of wave behavior. And after they can write that since diffraction was known to be a wave phenomenon, you don't have to put a diagram there, it's just nice to see what's happening. This observation, so I'm using cause and effect here, this observation confirmed the wave nature of particles. So 1 mark for mentioning the experiment here, 1 mark for mentioning diffraction, and 1 mark for linking diffraction with wave phenomenon, and hence concluding that electrons, when scattered from nickel crystal, form wave patterns. Let's do the next bit, C. Okay, explain why matter waves haven't been observed for objects larger than single molecules. That's 2 marks there. Okay, now going back to the de Broglie formula, lambda is h over mv. Objects larger than single molecule. Now, large, so we're assuming the mass is large. So if the mass is large, the wavelength will be small. If a wavelength is small, you can't see it. Okay, small wavelengths include that of X-rays and gamma rays, ultraviolet rays. You can't see those, right? So since wavelength lambda is inversely proportional to mass, you can write this in terms of ascendance, but I'm writing in terms of symbols. Larger mass indicates small wavelength, and hence that small wavelength is undetectable. Okay, so 1 mark for cause, which is large mass, 1 mark for effect, which is small wavelength. And that's your 2 marks there.